Hello and welcome. This video is for 10 on 10 competition conducted by Typhoon Hardware and Loop. We will be discussing the topic evolutionary computing based harmonic mitigation technique in novel 7 level inverter. This topic will be divided in 3 parts. First part will be detail of the inverter circuit. Second part will be detail of the control circuit, and then we will implement it on the Typhoon systematic editor, and we will be seeing its real-time simulation result in Typhoon SCADA output. Since multi-level inverters are extensively being used in medium to high power applications over the last 2 decades, as they offer versatility to handle power conversions. Now in this slide, as you can see, this is our proposed inverter and its power circuit diagram. This diagram consists of 6 switches, and each switch have one IGBT and anti-parallel diodes. And also it has two DC sources. One DC source have 100 volts and second DC source have 50 volts. This proposed inverter have many advantages because it is efficient and cost effective. This is so because it has only 6 switch and it can synthesize the 7 level output waveform. As well as I would like to suggest that this proposed topology is ideal for single phase applications. Now, total harmonic distortions is one of the important criteria for analyzing the power quality of output voltage waveform of the inverters. Total harmonic distortion spectrum contains a range of frequencies in which lower order harmonics are dominant, as these leads to an increase in the size of filter components. Now the parameters of control circuit of our proposed inverter is designed by evolutionary computational techniques. These techniques are used to minimize total harmonic distortion in output synthesized waveform, which is generated by our inverter. By using this control circuit, we can optimize total harmonic distortion to a minima without using any bulky filters. Now, we will move to our simulation part of our inverter. We will be doing our simulation in Typhoon Hill systematic editor. Now, we are in our systematic editor of Typhoon Hill. This is our inverter. This is the control circuit. Now we have attached our inverter to the control circuit. Here we are supplying power to the lagging load. This switch is implemented to test the dynamic performance of our inverter. This is the coupling transformer. The main role of this transformer is to divide our power circuit in two cores of Typhoon Hill, because one core can only handle 3 power electronic switches. Now we will compile an open model in Hill SCADA. Since we don't have any hardware to attach to the software, so we are loading our model to the virtual device. Now this is our SCADA panel, and we will be assigning 100 volts to the link voltage 1 and 50 volts to the link voltage 2. Now we will run our model and observe the load voltage and current load. Now here I am going to select the load voltage in viewpoint 1, and load current in viewpoint 2. Now here we are getting the waveform, synthesized waveforms of the load voltage and synthesized waveforms of load current. I hope you would have liked our video. Thank you.